afternoon, Professor. This is Team 5, and this project is about detecting cyber attacks in modern vehicles using machine learning models. Today's vehicles are not just mechanical, they're complex computer networks where multiple electronic CU units communicate through something called the CAN bus. This is the CAN bus. The CAN bus does not have a strong built-in security, so this makes it vulnerable to attacks like DOS, where an attacker uses a botnet to flood the network with fake messages and disrupting normal vehicle operations. So this project, we built a machine learning model to detect whether a CAN message is normal or a part of a DOS attack. Okay, we used a real world dataset called the vehicle CAN traffic. So each sample contains timestamp, CAN ID, data length, and the payload bytes. So we process this data by cleaning and standardizing it, splitting into training, validation, and testing datasets, converting into suitable for the machine learning model to understand. So then we try to classify each data and message as a normal traffic or as an attack traffic. And the technologies are used. The Python is used for the overall development, and NumPy, the library of Python, has been used for custom transformer model from scratch, and the scikit-learn for data pre-processing and the evaluation, and the matplotlib for visualization, and Google Colab for training and experimentation. And this is our transformer model. Instead of using traditional models like the random forest and the LSTM or a random classifier, we use this transformer architecture, which uses attention mechanisms to understand relationship between different features in the data. So to classify the results, we used multiple model evaluation metrics: the accuracy, the precision, recall, F1 score, ROC, AUC, average precision. You could see in most of our cases the ROC AUC is close to 0.98, which shows that our model can strongly distinguish between a normal traffic and an attack traffic. And so these are the various graph representation, the training and validation loss, the ROC curve, the precision recall curve, which shows that most of the models perform. You could see the baseline is 0.21, so it simply suggests that the model is really good at performing. And to conclusion, the project shows that how machine learning model can improve automated cybersecurity by detecting attacks in real time. Talking about our data set, this is our data set. As I told you, the timestamp represents each time event that the attack or the DOS call has been called, and the CAN represents each sample. So consider saying 790, 399 says that 2 cars were involved in this DOS attack, and this BO, B1, B2, B3, B4 are nothing but the payload bytes, which means these are the number of messages sent to this particular CAN ID. And you could see this column label says R for an attack and S for it wasn't an attack. So this label encryption shows this string has been converted to bytes, so binary numbers as 0 and 1, which is very easy for our model to understand. And talking about the output,